All right, yo, this is Educational Round 108. And just as a disclaimer, this is going to be rated for me. And just to give a little bit of background, if you can skip this if you want, but pretty much I always bomb education rounds or I do really well in them. And I feel like there's rarely any in between for that. So this is going to be really interesting because if I fail, then you get to see me fail. And if I do really well, you get to see me do really well. But yeah, that's aside from that, that's pretty much it. Let's see, there are about 10 more seconds until the round starts. If you're competing, then good luck. If you're not competing, then congratulations. Yeah. Several. So you have at least one red bean. Wait, what? I could distribute them among several, maybe one packet in such a way that each packet has something like this. Okay, so it's a yes or no question. Red, blue, and the distance. So okay. Let's see. Every bean I feel like it's just like division, maybe. B. Okay, well, R is strictly greater than B. Then R is equal to R plus B minus B equal R. So we just swap these numbers. And then if they have a matching bean. Yeah, so I guess it's like a greedy. Long max per is equal to we have R buckets. Out of these buckets, we can have at most D plus 1 beans in them. Yeah, these are how many? And then if max per times. Wait, yeah, okay, if max per is strictly less than B, then okay, let's see if this is right or not. Okay, yes, yes, no, no. Wait, can there be, wait, hold on, can there be 0 beans? No, there cannot. Okay, it's probably fine. It's probably fine then. Okay. See, problem B. I need to move this monitor a little bit. You have an n by m grid. You're standing on cell 1. You're going to finish here. Standing here, you can either move right or down. Wait, but the number of right and down moves stays the same, right? No matter what path you do. So isn't it just checking to see if that original cost like works or not? Oh no, okay, I see, I see. I see. Okay, so move right. Oh, okay, so in one move, whichever column like stays constant is what you add on to your answer. Okay, 10 to the 4, 10 to the 4, 10 to the 8 is too much. Let's see. If we have, let's, is it one indexed? It is. Okay, so 1, 1, 2, 3, 2, 3, 4. So path like this would be which case you're already in final cells, you spend 0. Okay, so this you spend 1, you can still spend 1, and here you can spend 2. You spend 2, otherwise you go over here and spend that much. Let's see. Oh, okay, but then you move that much. Okay, so every way. Okay, so you have to make like this many moves down no matter what. Okay, so if n is strictly greater than m, and we swap them, and then because for the smaller side, we're always going right or down, so we have to go to like each of these bottom cells at most once. And then for the rest of these values, it just depends on the coefficients that we assign them. Yeah, because we have, how many moves do we have? We have 1, 2, 3, 4, 5. We have 3 plus 4 minus 2, which is equal to 5 moves. Yeah, we start off with 1 occurring 0 times, 2 occurring once, and 3 occurs once. So these are fixed moves. We can 1, 2, 3, then those get that. Okay, so it's pretty much like you have to assign coefficients. That's like how this works. Can we use a greedy or like a knapsack? Maybe it's just a knapsack. We almost did print yes or no, right? How would a knapsack work here? Okay, I'm gonna try knapsack because I think it's. Wait, no, it's 10 to the 4. No, that's still a little too much, I think. Because it's 10 to the 4, there's up to n plus m elements. Wait, n plus m elements. I'm gonna try it. 4. Oh wait, no, it's not really a knapsack though. It's more of like you're just assigning values. Or like, yeah. Okay, so for cost, you could either do this or you can do something one less than that. Oh, okay, we find the maximum and the minimum cost and we just have to show that it's an interval. Yeah, okay. And I'll do long min is equal to 0. For I is equal to 2, I is also equal to n, I plus plus. And then min plus, so we assign the rest of them to 1s, so it's pretty much n plus m minus, no, n plus m minus 2. Wait, no. Oh wait, this total is 5, it's 3. We have to make n minus 1. Okay. Log max is equal to 0l. We do this, the same thing. Except now we do wait, is this right? Okay, so if we stay in this column, we add 1. Otherwise, it's from the column that we started from. Hold on. So no matter what path we take, there will always be a step in which we go into here and into here. Oh wait, shoot. It's the column. Oh god, I did not read this problem correctly. Okay, and it is pretty easy. Oh my god, I'm already choking. Let's see. Yeah, because if we go to 1, 1 to 1, 2. Alright, so we can do 1s and then 4s. Okay, so if we move over here, it's like all 1s, and then over here, it's like all 4s. The no case. Okay, no case is for 2. The 4th and the 5th. I just wanted what? Oh, you know what it might be? It might just be this. So r is greater than 0, dp min at r. I wonder if this is even right or not, but static final long always an interval? Okay, so if we have 1 plus 1 plus 1, so this is 3 times 1 plus 4 times 2, 8, this is 11. If the cost of that is 11, can we ever achieve 10? Or wait, or 12, I guess. Well, if we go, so this is 1, this is 6, and then 4. Wait a minute. This is 1. Wait. 1 over here. So that's 2 plus 1, 2, 3. 3 times 3 is 11. What if we do a path like here to here? 1 plus 2 plus 2 plus 3 plus 3. This is 6, 4. Oh my god, wait. Bruh. Is it just, oh my god, that's so troll. That is so troll. That is so troll, isn't it? Long res is equal to n times, or no, the number of columns, n minus 1 plus m times n minus 1. Wait a minute. I feel... Does it alternate yes and no's? Okay. I want to read the third problem while I wait for the page to load. Okay, M1. Let me in. Let me in. Let me in. Submit. Java 8, problem B. Polycarp is an organizer of Berlin thing. Okay, yeah, we got it. Dude, B is so troll. What the fuck? I was literally about to do DP, and then I realized, like, wait a minute. Well, we're not doing that well, but that's okay. Polycarp is an organizer of Berlin ICPC regional event. There are N universities in Berlin, number from 1 to N. You know, all competitive programmers in the region, therefore there are N students. Okay, so there's 2. Okay, so there's N universities and N students. IC universities enrolled at University U and has programming skill of this. Oh, okay, I see. Polycarp has decided on the rules. If he chooses the size of a team to be some integer k, each university will send their k strongest students and team next k strongest second team and so on. The strength of a team of the region is the total skill of the members of all present teams. What does that mean? Wait, what is that supposed to mean? Is the total skill of the members of all present teams. Oh, okay, I get it. I see. Oh, okay, I see. So it's pretty much like if we sort them in decreasing order, you just want to, we like ignore the, whatever like is mod left over, those people just get ignored. I see. Wait, so does that mean, so for k equals 1, it's just the sum of everything, and then it keeps on going down. Or it doesn't necessarily keep on going down, because if everything is divisible by a number, then it's fine as well. Yeah, okay, I see. Okay, how are we going to do this? Let's see. And that's it, right? Okay. Okay, so if we want to group all the students by their school and then sort them in decreasing order, what do we do after that? Do we want to go in increasing or decreasing? If it's increasing, it's just a sum of everything. Okay, so if we consider a list and the contribution changes only when, for every like divisor of a value it is. So this means, okay, if we can factor like the sizes of these students, well, I mean, it's not necessarily a factor either, because obviously when you have 6 students, they can get split like this, but even if you have like 7, they can still get split into multiple groups when k equals 3. Let's see. Maybe it's a range update. So like for each school, a student can only contribute to a team for, I mean, not for some set of values, but it's not necessarily a range either. It's only when its current school size mod value it's not in like the last mod of those numbers. Yeah. Okay, I think I see how this kind of works. Oh, this is a DP problem. Okay, hold on, let me look at because if it's DP, I could probably do it. Right now, you're given 2 of these. You can reverse at most 1 subarray of array A. You want to maximize a product sum. Okay, well, if we can pre-compute for every subarray, well, if we can find efficiently for every subarray, then we can just like find the prefix of it. Yeah, because for the reverse subarray, it's just, yeah, okay, I know how to do D. So I'm actually going to do D right now. Ten to the 14 times 5. Okay, it's long. Okay, well, if we do... Okay, so pretty much we want to find the prefix and the suffix, and we also want to be able to pre-compute for every reverse subarray what is like its corresponding value. So find reverse values int. So reverse to I is equal to array I minus 1 minus I. Okay, and then we do right, because if it's 1, 2, 3, 4, 5, 6, A, B, C, D, E, F. If we did F, E, D, C, B, A. If we wanted to correspond this reversal, it would have to go with some segment in here. If D and E was reversed, then okay, so for a reverse value, A and B BC, BCD, yeah, it seems kind of hard to calculate those values. Wait, okay, so we did E, D, oh, okay, so it's E, D, C, B, or if we only reverse this as DCB. If we only reverse this as CB, and then that one says B. Okay, maybe it's not as simple as I thought it was. Okay, maybe it's like dB of I, and then this is the right, and then this is like 0, 1, or 2 maybe. That's 25 million, 70, that might be a little too much. But if it's left and then right, let's see, if it's a left value and then a right value. That means we can yeah, but then that that value itself is kind of a constant value. Okay, so if we basically need to find a way to pre-compute if the entire subarray is reversed at that segment. Oh, okay, so we know some values. So we know 1 to 6, but we also know I don't think we know anything else, because there isn't like a pivot point. Oh, we know C. Okay, I see. We also know 2 to 5. We also know 3 to 4. Okay, yeah, I know how to do it now. We don't, yeah. So middle. So reversed subarray part. So reversed no subarray, because so these are the parts that we need to do. Pretty much, let's see. N and N. DP. Okay, N is at most 1. So I is equal to 1. Yo. No. Wait, hold on. If n is equal to 1, then we have to long array at I times ber at I plus 1. Okay. Let's see. Max of itself, and then we do long array at A times this plus long array at B times this plus dp at A plus 1 B minus 1. Okay. left is equal to 0. If a greater than 0, left is equal to prefix at a minus 1. Long middle is, no, long right is equal to 0. Res equals max res. Left plus right plus dp at a to b. $29. 174. 235. Oh my god. Java 8 for problem D. Yeah, CF is apparently down. That really sucks. It's testing. Okay. Time limit. Is it 2-second time limit? It is. Good. Yeah, that'll probably be fine then. Memory. Yeah, I think we'll be fine. Let's see, problem C. It's like the weird brute force thing, I think. Okay, it loaded. Okay, so we need to figure out how we can efficiently pre-compute these. Let me think. Have school and then raise. We definitely want to group them by their university value. Oh, you know what might be an easier way to do this? Because the sum of all of these groups aren't that large in the first place, we know that if for any n larger than the size of a number of students the university has, it's just going to be 0 no matter what. Yeah, okay, so we can probably just pre-compute everything then. Yeah. Okay, I know how to do this. Let's see. Store into buckets. Array list, integer, n plus 1, for int I equals 1, new array list of integers. So buckets. Okay, so the university of the ICE student. Right, and so for each like I, we can just like store the value. So for int SC is equal to 1, SC is less than equal to n, SC equals plus. Buckets at SC if ls dot size is equal to 0, then we can just ignore it. equals 1. V is less than or equal to M. We do this and then okay. So we do this and then long. I mean, it would be better to do suffix, right? Or alternatively, we can just like sort them in increasing order. Collections.sort ls. Int take int remove is equal to m mod v. Long temp is equal to prefix at m minus 1 if removed is strictly greater than 0, temp minus equal to the prefix of this res at v minus 1 plus equal to temp. That looks correct. Yeah, let's submit it. It is testing. Okay, we got C. Now we just need to figure it out. Okay. Do 2 points. Endpoints on an infinite plane. Oh god, that's annoying. Wait a minute. Why wasn't it not updating? Maybe it's just lagging. I don't know. Yeah, I guess servers are really slow today. So we can either increase just 2 points that are not equal to each other. We can move them out. Wait, what the fuck? What the fuck is this? Move point A from here to here. The move can only be performed if there exists a line that passes through the new coordinates of A, new coordinates of B, and 0. Wait, it passes through the new coordinates. Oh! Oh, okay, I get it. What is the maximum number of moves you can perform? And you have to actually output the moves themselves. Yeah, this seems like a really weird problem. Also seems kind of difficult. Yeah, it is kind of difficult. Is there a reason why I don't show up? Wait, there has to be a reason why I'm not showing up, right? I don't know. Off by 1. Maximum number of moves you can perform. They're all positive. Okay. So we can either increase the numerator or the denominator. Okay, so the lowest point, the point with like a smallest slope, we never want to decrease its, we never want to increase its denominator. We always want to increase the numerator. And so that would have to work. Okay, so it's like every point can essentially have 2 states like this. choose these states such that as many of these states are made the same as possible. Okay, yeah, problem E does seem, at least for now, it seems kind of difficult. Also, I think I know why I don't show up here. I think when I registered for this contest, I was still orange. And that was like before the ratings updated from the last contest. That has to be why. I feel like that has to be why. Yeah, that would make a lot of sense. Okay, so let's assume that this is what I'm like right now. Okay, just like me. Okay, just like a little bit faster. Yeah, I was definitely a little slow at the beginning. Maybe more like this? Yeah, about that. Only 24. Oh god. That's not gonna make it worse then, is it? Alright, so there's a little bit of pressure to solve E. I feel like more people will probably get it as time goes on. Okay, so the point with the... Yeah, well, like any point with the smallest possible, like, slope. Like, yeah, any point that starts with the smallest slope. If we were to ever make a slope smaller by increasing x, right? Wait, what? Hold on. Yeah, increasing x would make the slope smaller. So, because it's the smallest possible slope, there don't exist any other points. So that if you were to shift it that way, it would make it better. Right? Because if a point was like this and then this, if they had the same slope in the first place and didn't correspond to the same point, they would just shift over by 1. The relative positions don't change. Yeah, okay, so that means points with the same slope in the input can never match together. So I guess that's one thing to notice. Okay, so points with the smallest initial slope have to increase slope be matched. Points with same initial slope can never pair together. Okay, so those are two like important things. I feel like they might be important. Okay, so let's assume that we took all the smallest points and then we moved them up. Then we have to figure out if there exists another point up here that can match this way. What if we constructed this as a graph? Wait a minute. If we constructed this as a graph, what would that mean? Well, every node would have like, yeah, we would have this many nodes, something like this. Can 2 points ever pair together if they make the same initial move? Well, yeah, I mean, clearly. If we have something like 1, 2, something like 2, 4, our initial points could have been something like, even if it was like 2, 4, and 3, 6, they have the same slope. Our points were initially like 1, 4, and then like 2, 6, then we can increase them like that. What would 1, 4, and 2, 6 look like? So Desmos plot point 1, 4, and 2, 6. Okay, and then 2, 4, and 3, 6 would be 2, 4, and 3, 6. Right, and then that would form a line. Beautiful. Okay, so if we had a graph, okay, so if we constructed a graph such that it was like this could pair up with this could pair up with that, this could pair this with this. Wait, no, this can never pair with that. Let's ignore that. I want to find the maximum matching. But the problem is that we can't take nodes that have already been taken once over here. What are the constraints on this problem? 200,000, 2 seconds. Okay, it's probably not flow then. What about like edge matching? Edge matching in general. We have this. One, 6. Five and 7, 1 and 6, 2 and 4. Isn't it supposed to say 2 and 4? Or like, wait, I think it's. Wait, this sample looks kind of weird. Or like the graph, or like the picture that they give. It doesn't seem right. That's okay though. Can remove points A and B. If points can only match together with the same, or like could match together, Okay, is it possible for something like this to happen? Okay, these slopes have to match, but these slopes have to match. But if they're not, okay, is it guaranteed that there aren't any points that coincide? It doesn't say. Is there an input that mentions that? Maybe it's just greedy then. So like if for all the points with the smallest slope, we just increase them by 1, we figure out if there's a point that can potentially match with it. And if there is, we can always take it. Right, because we remove the 2 points anyway, so whether or not we like, and because these points can't ever be a part of anything else. Yeah, okay. Wait, 1, 4, 2, 6. 1, 4 has, no, 2, 6 has a smaller slope. So we increase it to, so we have to increase it by 1 to consider matching it. Wait a minute, hold on. That doesn't seem right. 1, 4, 2, 6. What about? Okay, this is 2, 4, and 3, 6. They form a line over here. Oh, these like already form a line. Oh, okay. This is not necessarily true. Because of this example. Okay, well, points that can match together have to be close in their slope in the first place. Because we're only like increasing or decreasing them by 1. So they have to be relatively close. Yeah, point can never match with itself like this. Let's see. Is it ever possible to have that happen? Time limits. They're kind of slow. let's see. What is... Is that ever possible? Is it ever possible for an x to increase by here for this, and then like another point? Okay, I need to figure out whether no. Okay. So points can coincide. So if points can coincide, that's interesting. But I mean, then again, there wouldn't be an edge over here in the first place. Okay, if we put them all on the hash map, what that means is max matching of a graph. I'm assuming this is NP complete or something, right? Yeah, NP hard, stuff like that. Are there special properties of this graph that we could abuse? Is it bipartite? I don't know if it's bipartite or not. I feel like it's not. Yeah, okay, let's see. If we had A, B, C, D, E, and F. A plus 1B, C, D plus 1, E, F plus 1. So is it possible so if we do something like if we do I don't know, what is 10 million? Well, 10 to the power of 7. Well, 10 to the power of 7 over 6 would be... Okay, wait, no. That's not an efficient way to brute force it. Right, because everything has to increase or decrease. A minus and B is like this first point. Or, okay, I guess, hold on. If a point over here, okay, so if it has like a +1 and a +1 relationship, then it looks something like this, meaning that if we had a point, if it's, no, both of these x values increase, but if there's a point that coincided such that the y value increased, so for example, if this went to 2, 4, and then we had like 3 and 5, and then the other point is like 2 and 6. Both of these could coincide depending on how we shift them. But, wait a minute. Yeah, because this could be 3 and 6 like that, while this one just shifts over. Can these 2 points, the 2 and 6, 3 and 5, yeah, they can both become 3 and 6. And they both fall on the same line. Okay, so these can match. These can match. And these can match. Okay, so it is not bipartite. Okay. Interesting. Okay, so what if we, okay, if we were to think about like grouping these values and then okay, so we know that this is not necessarily true. If we grouped numbers like this, every number can be our most 2 things, and when we take out 2 numbers, those other 2 occurrences are also removed. And we have to maximize the number of these moves we can do. It might be based on the what is the like largest group we can do. So if we think of it as like we first group, there's up to n groups, right? So then if we imagine taking 2 numbers out, greedy? Okay, what are the runtimes looking like here? Okay. If it's greedy. So if we have like A, B, C, C, and then like D, E, E. Well, these can never affect each other. So if it's like for like a certain group, if we want to remove from like a value, then it depends on where we want to remove it from. Yeah, because if we do it like this, okay, so let's think of these as components. So this is component 1, component 2, component 3, component 4. 1, 2, 3, 4. This has an edge between it, 1 and 2. B has an edge between 1 and 3. Is there an edge between 1 and 4? No. Okay, so A's, the C's form an edge from 2 to 3. D's form an edge from 2 to 3 as well. And then E's form an edge from 3 to 4. Okay, so if we model it like this, the problem is equivalent to just picking any two edges that have a common, they have to have a common endpoint, that share at least one common endpoint, and then removing both of them. So if we had something like 1 and 2, right, so it's like if we had AA, if we matched A and B, we have to remove the values from A, like 1 and 2 and 1 and 3, and that increases 1 to our answer. Huh. Is it easy to keep track of which nodes, which values we should remove? Yeah, okay. Oh, this is the index of a point. 1 and 6. Four over 1, 6 over 1, 5 and then, yeah, 5 and then 6. Okay, if there are edges that go in both ways, do we want to remove them necessarily? Or no? I don't think we have to necessarily remove them. Let's see if is this a well-known problem? Maximize the number of moves where in one move you remove two edges in graph, sharing at least one node. Maybe you can do this greedy. So like after we construct this graph, there's only one edge going from 3 to here. No, but that doesn't seem right. Wait a minute, is it always possible to do something like this? We had a node over here and a node over here. Okay, this is an even degree, this is an odd degree. So I mean, we can clearly remove anything over here if we have something like this. Even, odd, odd. Okay, well, I mean, if there's an odd number of edges, then obviously we have to do it in terms of an odd value. Yeah. So this is going to be like a multigraph. Wait a minute. Is there always a way to remove these such that we have at most one edge remaining? I feel like it's probably not true. Although, wait a minute. Pick any random node. If it has an even, like, out degree, that means we can match everything with it. And then the edge from that node to this gets removed, and then it gets reduced to, like, smaller problems. Okay. But if there's only one edge, we pretty much remove it, but we don't, like, do anything with it. Wait, no, but we don't have to remove it, though. Yeah. So, anything with a degree of 3. Depending on how these nodes turn out. Wait, is it possible to have a graph? In a graph, out degree of one node is even. Isn't there a property like that? Let G be connected graph with an even number of edges. Show that G can be oriented such that the out degree each vertex is even. Show that G can be oriented so that the out degree of each vertex is 0. Oh, okay, so this is a property. So we need to pretty much just remove. Yeah, so when we form these components, if a component has an odd number of edges, then we just we can just like ignore it. If there's an odd number of edges, it's possible that it forms a tree. But if it forms a tree, and we remove any one of these edges, then it'll decompose anyway. But what if it decomposes? I mean, we can just choose a leaf and then guarantees be like 1 and then 0. Yeah, because it has an odd number of edges, we don't want to remove this edge because then it gets 2 odds. We just want to remove this edge, so then it's 1, 2, 3, 4, 5, 6. Okay. So for each edge, if it can decompose into this and then this and then this, let's assume key is connected to an even number of edges, take an arbitrary orientation of key. If any vertex has odd out degree, there are at least 2 vertices with odd out degree, and the sum of out degrees equal to the number of edges. Okay. Choose 2 vertices such that they're odd. We know there's a path from U to V. Reverse the orientation to each edge of P. Into segments of length 2. Does this make sense? If it was something like 1, 2, 3, 4, taking this is bad, taking this is good. Taking that is okay. So for each component, okay, so for each component we pick the one, we start with a node with the smallest out degree. Go up here and then just choose an arbitrary node. See if that's okay or not. And then that gets decomposed. I don't process it unless that many times. Okay, I'm gonna try it. My way basically does it greedy on a graph. We want to map. Yeah, we want to normalize everything, so we want a GCD function. The buffered reader. Or do we use fast scanner? I want to use fast scanner. Let's see. Cut, paste, refactor. Okay, they're all at least one and they're all integers. So we can just use integers here. A over G, B over G. Okay, and then we do what do we do? What do we do here? Oh God. Wait, no, this is a little bit different. Right, because int x is going to be equal to is equal to get Actually, wait, we don't even need this. We just need C plus D. We do edges at V, or ow. Int A equals map dot get IDs at I at 0, and B equals map dot get IDs at I at 1. Edge class, because we need to do a few things. If it's a line like this, we don't want to just delete this here. We want to do it like this. So what this means is that we have to start from okay, I see. before edges occur. Wait, but then we want to sort them by their... Wait a minute, hold on. Can we remove edges? We want to remove them from components with smaller degree, or like nodes with smaller degree. Right? Yeah. Okay, so for each value, Control R, deck with list. It's the same thing over here. Want them increasing. Except it's x dot. X dot 2. Okay. And now we might be able to do this stuff over here. Where if edges at cur.size, well, while it's at least 2, we do this. Okay, and then we do indices, true. Okay, edges.cur.get dexes of cur. So while edges up, cur.size minus dex. Dexes at cur is at least 2. Then we do this. And then the idea is that these edges are already removed. So then it's we just do res.add a.id, res.add b.id. Okay, that's like initial size. Yeah, we only remove edges from components that have already like been removed. So I don't think that's I think that's the reason why we don't need to update it. Let's see. Oh, okay, hold on. Oh right, we have to remove these too. So 1.6 is obviously one thing. 2.3 does not seem right. Wait. Oh, because we actually need to remove the edges, right? So for a given part, or like say over here, I mean we don't do anything over here. We pulled this edge, and we pulled this edge. It might be better to just do it as like how many edges there are. I was gonna say this many. If to remove or then we want to skip it. And we can like keep skipping this value if we want. Is equal to this, and then edge B is equal to this. Same thing over here, except we do b.id, and B is equal to this. And if not removed at a.id and not removed at b.id, then we do this. And then I'm gonna just assume it's correct, because I don't know if it's a case of like having multiple correct answers or whatever. Let's see. Oh god, it's broken. M1, enter. See, will it load or not? I would prefer for it to load. I'd prefer for it to not be stuck in the queue. Wrong answer, test case 5. Huh. Interesting. Is that a common one? Test case 7. It's hard to say. Maybe it's like the way the active. Oh right, because the active the size of everything keeps changing. So then it's like int size is at v is equal to edges at v dot size. Okay. And then over here we do sizes at x. Minus sizes at y. Okay. And then these are like removing edges. Okay. Update sizes. We care about where it's 2, yeah, and so sizes at so if active dot contains a.2, then active dot remove a.2, sizes at a.2, and then active dot add a.2. If active dot contains b.2, how sizes at b.2 decreased. Same thing over here, except it's b. B, B, B. Submit. I have to open this up to get the samples. I know, it's still test case 5. How many solves? Okay, well, I can't even check. Is this correct? Okay, that looks fine. The GCD, we don't have to update the GCD yet if we initially updated it like this. 80 at 0, 80 at 1. Do we have to like sort these edges in some way? Like maybe we, okay, sizes is kept up here, then we do this. Except it's x dot 2. Dot 2, dot 2, dot 2, dot 2, dot 2. Control F. Maybe instead of array list. No, I mean, then maybe like need them to have like another tree set edges. That just doesn't seem right. Is it though? Why is Codeforces not loading? What's going on? A and then D. Greater than or equal to 1. Shoot. Ah, shoot. Oh, shoot. That's a problem. Is that the only problem? I don't know. But I know that is a problem. Okay, it's not the only problem. Okay. Yeah, I'm not sure then. I am not sure. What is wrong with this? IDs, ID, ID. Okay, yeah, I don't know. But yeah, E was pretty hard this time, right? Yeah, only 57 solved. That's really difficult. Okay, how are we doing? I mean, it doesn't even show up here, but yeah, it definitely seemed like a Speed Forces round pretty much. Yeah, that's not fun. Speed Forces is never fun. Okay, that's pretty much it for my screencast. I want to look into see if my E was right at all or not. But yeah, see ya.